Welcome, Golden Valley Knights, to our very first seventh grade remote teaching lesson. Are you as excited as I am to get this started? The first thing that I want you to notice is that our notes look different, unlike they've ever looked. Well, that's because you don't have a printer at home to print our notes out easily. So I'm going to write down our notes how yours would look as well. So I've used a very basic sheet of paper. Anything that you have to write on will work. But we do want you guys to write these equations or these notes down so that not only do you have them for reference to look at this year, but for next year as well. Let's go ahead and dive right in. So again, like I said, we're working on solving simple equations, and this is week 3. Our objective, what we want to be able to get done by the end of this lesson, is a 6th grade standard 6.EE7. We thought it would be not only a good bridge to what we need to be able to do for the 7th grade, but a good bridge into this whole remote learning situation that we find ourselves in. So today's objective is I will learn how to solve simple equations using DC math. Simple equations because they're only one step to solve them, and DC-MAM is that strategy that we're going to be using. It's an acronym that stands for something. We'll talk about that a little later. Kind of like how for adding and subtracting integers we use CSAS, well, for solving equations we use DC-MAM. We're going to start this lesson off with just some vocabulary words. There are going to be 2 words that we're going to be using on and on during this lesson, and they are equation and inverse operation. So it's very important that we talk about what these actually mean. Equations, you might have heard of that before. They say that 2 expressions are the same or equivalent. Our second word being inverse operation, which is the operation that undoes another, or it reverses it. It is the opposite operation. For example, for addition, that operation, the inverse operation is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse operation of division is multiplication. Before we talk about how to solve equations, I have to tell you a couple of things about equations. When you solve an equation, your goal, your big goal, is to isolate the variable or get the variable by itself. So we're going to isolate and we want to get it by itself. Once you have done this, you would have solved that equation. The strategy that we're going to be using to solve equations is called DC-MAM, D-C-M-A-M. The D in DC-MAM stands for distribute, the C stands for combine, the M stands for move, the A stands for add and subtract, and the M, the last one, stands for multiply or divide. The good thing about all of this is we're actually not going to go through the first half of DC-MAM. That's going to be saved for 8th grade. So we're not going to distribute, we're not going to combine, and we're not going to move. So DC-MAM is used to tell us the order in which we do things. So we would add and subtract first, and then we would multiply and divide, which is kind of the opposite of your order of operations. But remember, when we're solving, we are working with inverse operations, which remember, they undo each other. That was the hard part. Let's get to the easy part, actually solving them. There are some very easy steps on how to solve equations, how to solve simple equations, and actually all equations. One, we're going to draw a wall. It sounds weird, but we want to split our equation into 2 sides, the left side and the right side. Next, we want to circle our variable. We want to see where our variable is at and ask ourselves, is our variable isolated? Is it by itself? If so, we reached our goal. If not, then we're not done yet. Then we're going to go ahead and use DC-MAM. And our last step is we're going to check our answer because luckily with solving equations, we'll know if we're right or if we're wrong. You're almost done. Two equations, and then your work for the day is finished. All right, let's go ahead and start solving. Example number one, we have this equation, x plus 17 is equal to negative 30. I want you to notice that I already wrote for you DC Mam on the side. Again, this is our checklist to tell us the order in which we do things. So I want you to write it for every single one. So now I'm just following my steps. Step one, draw my wall. So right down through the equal sign, I'm going to draw a line that separates my equation from the left side and the right side. Next, it says for us to circle our variable. Our variable is x, and it is right here. So my question is your variable by itself? No, it's not. It's next to that plus 17. So we want to move that plus 17 to the other side. And how we're going to do that is by using our DC Mam. Again, good thing. We don't have to distribute, we don't have to combine, and we don't have to move. Now, what do you see in the equation? Do you see addition or do you see a subtraction? I see addition. So we're going to do the inverse operation, which is to subtract. Since I see that we're adding 17, this is what I see, what I'm going to do is the inverse operation, which is to subtract 17. I want you to notice that I wrote it right under that plus 17. We want to keep things organized. So I'm going to write it right under there like I did. And again, math is all about balance. So what you do to one side, you do to the other. And I'm going to draw a little line to separate to show where my answer goes. Here we have a 17 minus 17. This gives us 0. That's exactly what we want. Now we need to bring down your x equals, and now we have to evaluate or figure out what's the value of negative 30 minus 17. The good thing is we've gone through our CSA strategy here, and we went through the first couple of steps already. We don't need a circle, we don't need a stack, it's already stacked. So now we need to decide, do we add these or do we subtract these? Since the signs are the same, we're going to go ahead and add them. Signs are the same, so we do add the numbers together. So we have 0 plus 7 is 7, 3 plus 1 is 4, and then keep the sign of the bigger number. Since the 30 is negative, this stays negative. So here we have x equals a negative 47. And wouldn't you know it, here's our variable. And what you notice is that it's by itself. That's why they call this a one-step equation or a simple equation. There's only going to be one thing that you need to do to solve it. That's it, you're done. X is equal to negative 47. Your teacher's really going to love it if you box your answers like we did here. Technically, you're done, but we really want to know if we did this right. So I'm going to go ahead and check it. So I figured out that x is equal to negative 47. The process that I'm going to do is to substitute. I know x is negative 47. So I'm going to replace the x. What I like to do is whenever I see an x, I'm going to put parentheses and then copy everything else. So x plus 17 is equal to negative 30. And then I'm just going to put into those parentheses the number that I found x to be, which was a negative 47. So now I have negative 47 plus 17 is equal to a negative 30. So we want to see if that's true. Since it's an addition expression, I do want to go through my CSAs. So I'm going to circle. I'm going to stack negative 47 on top of a positive 17 because it has the bigger absolute value. And now I need to decide if I add or subtract. Well, since the signs are different, I am going to be subtracting the numbers. 7 minus 7 is 0. 4 minus 1 is 3. Take the sign of the bigger number, which is negative. So we know the value of negative 47 plus 17 is negative 30. So the question is, does negative 30 equal negative 30? Sure does. They're exactly the same value. So our answer of x equaling negative 47 is 100% correct. Great job. Last example. Let's go ahead and do it. Example number 2, negative 5s is equal to a negative 45. Again, notice that I wrote down my DC mam already. Great thing about it, we don't have to distribute, we don't have to combine, we don't have to move. Oh, and actually going back to example number 1, we're now done with adding and subtracting and multiplying and dividing. Okay, back to it. So you're going to see something really funny here. I don't see an addition sign, a subtraction sign, a multiplication sign, or a division sign. When you have a number, like the number negative 5, next to a variable, a letter, like the letter S or the variable S, that means the operation is multiplication. When you see a number next to a variable, the operation is multiplication. We are going to need this for later. All right, let me go through my steps. Step number 1, draw my wall, separating the left side from the right side. Step number 2, circle the variable. My variable is S. There it is right there. Is it by itself? No. It has that negative 5 right next to it. So there's some things that we need to do. Going through now our DC mem. Again, don't need to distribute, don't need to combine, don't need to move. I don't see any addition or subtraction. I do see that what looks like a minus sign right here, but I know that that's a negative because there's no other number in front of it. So that's definitely not a minus sign. But what I do see, since a number is next to a variable, is multiplication. So that means that we're going to be needing to divide. I see that it's multiplying by a negative 5. So what I need to do is divide by a negative 5. How we're going to show we're dividing is not using that silly division symbol, the line with the 2 dots. Now we're going to use our fraction bar. So this here, this line, that's actually a fraction bar. So again, I see that we're multiplying by negative 5, so I'm going to divide by negative 5. Notice the number stays exactly the same. Now, what we do to one side, we do to the other. So since I divided the left side by negative 5, I'm going to divide the right side by negative 5. The good thing is, negative 5 divided by negative 5 is 1. So there you go, giant 1. So I'm left with S is equal to, negative 45 divided by 5. Now, if you're not good with your multiplication or division yet, that's okay. Just use a calculator. Well, there's a calculator on your Chromebook, and you're more than welcome to use that. Since I do have at least one negative, I know that I'm going to be using my dead man, there he is, to figure out what the sign is. So now 45 divided by 5, well, that's going to give me 9. And the sign is going to be, well, since the 45 is negative, I'm going to cross out a negative. Since the 5 is negative, I'm going to cross out a negative. So I know the sign of my 9 is positive. So my answer is positive 9. And I know that's my answer because my variable is by itself. There is nothing next to it. S is the only thing on that left side. So technically, we're done. But I do want to check my answer. So to check, we know that S was equal to 9. What I'm going to do is copy the equation, and whenever I see an S, I'm going to put parentheses. So first I see a negative 5. Oh, there's my S. So there goes some parentheses, is equal to negative 45. And the thing that I put into those parentheses was my answer, which is a 9. This one's actually a lot easier than the previous example because multiplying to me is easier than adding and subtracting. So we have 9 times 5, which is 45, but uh-oh, I have a negative. So here's my dead man. The 5's negative, cross out a negative. The 9 is positive, I cross out a positive. So I'm left with a negative 45, and that is equal to negative 45. So all I did was copy, bring this down. So since negative 45 is the same as negative 45, I know without a shadow of a doubt that I solved my equation correctly. The answer is S is equal to 9. And we're done. Great job. That's all you have to do for today. If you have any questions, write them on the margins where it says questions, and you can bring them to the live session that we will be having either Tuesday or Thursday. And if ever you have a question, you're always more than welcome to email either of your teachers. I hope that this wasn't too bad for you. And I think that's all for me. So, Miss P, out.